Okay, like yesterday we have just stopped in discussing the indexing and slicing and advanced indexing, arithmetic operations and all stuff. Out of which, let me just cover up the indexing and slicing. If you can take a look at this part, import NumPy as an NP, np.arrange of 5. If you can take a look at this part, we know that this A will give you the numbers 0 to 4, and A of 1 represents 1. Why? Because it starts indexing itself will starts with a 0. 2. Minus 3 represents it's a reverse indexing. Okay, 2. Why? Because you will have the value something like this: 0, 1, 2, 3, 4. And even indexing starts something like this: 1, 2, 3, 4. Okay, so in the same way here, reverse indexing starts with something like this. Here you will get the minus pi, of minus 5, minus 4, minus 3, minus 2, and then minus 1. Okay. And whereas the normal negative indexing minus 1, minus 4, minus 3, minus 2, minus 1. Okay. Okay. This is how the indexing will goes ahead. Okay. So NP of diagonal, NP dot arrange of 3. So a range of 3 represents 0, 1, 2. A of 0, first row of all the elements 0, 0, 0. A of 1 comma 1 will access a single element which is 1, 1 comma 3, which represents 0, 1 comma 3. 3 represents, definitely we should get an error. Why? Because we have only till 2, 0, 1, 2. Okay, index 3 is out of bounds for access 1 with access with size 3. So let us see this array, one more array. Here we do have an array again. Okay, understanding the second column, 0 and 1, second column 0 and 1 starts with the indexing 0 and 1. You can see an array which is consisting the column as a row and the 2, 3, 7, 7. Okay, 5, 6, 7, 8, 0 and 1. Okay, slicing. So NP of arrange will give us the values since from till from 0 to 19, and here you can observe A of 5 till 20 with a difference of 5, showing us 5, 10, 15. A column 4 This is till the fourth index of the data. 0, 1, 2, 3. Next one. This is till 10th. This is till 1 to 5 represents 1 to 4. 5 is exclusive. 5 colon means from 5 onwards. Okay. What this will give? You please tell me. Anyone? We have already given something like this here. 5 colon 20 colon 5. Okay. It cannot consider 20. Why? Because the arrange function can give you the values only from 0 to 19. So divisible by 5 across all the numbers, you are going to get 5, 10 and 15. It is not before 4. It will give you a multiples of 4. Take a look at this one. Why? Because when you don't mention anything else colon, you didn't mention anything colon 4, means you are including all the values with the separation of 4. 0, 4, 8, 12, 16, something like this. Okay. Okay, can you tell me a of 0? Okay. So we're done with the indexing and slicing. Advanced indexing. Take a look at this one. Yeah, that's good. 0. See, import NumPy as np.array. We have the 3 by 2 matrix. I'm sorry. This is a 3 by 2 dimension array. 3 rows and 2 columns. Okay. And you can observe the two indexed values 0, 1, 2 and 0, 1, 0. 0, 1, 2 refers what? 0, comma 1, comma 2. 0, comma 1, comma 0. Hmm? See, we will have the two indexes. One is a row index and another one is column index. In the row index, we have something called a 0, 1, 2. In the column index, we have only 0 and 1. From the 0, from this one, 0, 1, 0, 1, 0 and 1, which refers to 2. So now, here, we are trying to select the very specific elements by giving this part. 0, 0 gives us 1, 1, 1 gives us 4, 2, 0 gives us 5. Coming to the x of 0, this gives us the very first row, x of 0 comma 1. 0 comma 1, 0 comma 1, 2. 0 comma 2. Why? Because individual arrays. 0 comma 2 is in out of bounds, right? Why? Because 0 and 1, we do have only two column names. 0 comma 1 plus 1, we can do the additions, means multiplication to the existing array element, adding. Okay, so you can do the additions. 1 comma 3, something like this. Okay. And you are making a one more, adding a one element to the entire uh, array, and you are going to get a result something like this. Okay, all of you, understand this concept. Okay, so Boolean indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you are going to mark this up, this is a 4 by 3 matrix. X of x is equal to 0. Whenever you say something like this, it will return you the values wherever you have the value 0. So wherever you have the even numbers, you could get printed all those numbers over here with the given numbers in the array. Okay, are you all good with this? Narayana, if you don't understand anything else, please let me know. I will repeat one more time, no issues. I don't mind repeating. Ashok, Narayana, Ramdinesh, Sunil, Suresh. Okay, you're good. Okay, I'm taking it for granted, and I'm just going for the other arithmetic operations. See, when we have the couple of entities inside this, we can always do the multiplication. Okay, addition, multiplication, division, power, reminder, all this kind of stuff. Just let me just go ahead in a single go. We can't go it. That's the problem here. Okay, division, power, reminder, something one like this. So next, let me just switch to the mathematical operations. We have various mathematical operations that we can do with the NumPy. Okay, sine of np dot pi by 2. What do you mean by pi by 2? Is it 90 degrees or not? Pi represents 180 and sine 90 degrees. One, right? Trigonometry. Cos 90, 6.12. Tan 90 degrees. Okay, np dot pi by 2. See, rounding operations over here, we do have some set of values. Okay, I just want to show you. Everything is in some negative values, and almost everything is a decimal represented values or form, I mean, possible points. And the floor of x. Floor of x represents, it will just cut off all the decimals. Seal. Sealing represents, it will round off all the values. Look, 1.7 rounded off to 1. Okay, minus 0.4 rounded off to minus 0. 1.5 rounded off to 1. 1.6 rounded off to 2. 1.9 rounded off to 2. Trunk. Trunk represents, cut it off, whatever the decimal after point, whatever the digit after the decimal system, it will be pruned. So next one, sum of multiple arrays. 1 plus 2 plus 3 plus 4. Sum of with axis 0 means only the columns. Axis 0. When I say axis 0, it's only columns. Okay. 1 plus 3, 2 plus 4. Axis 1 represents rows. Rows. 2 plus 1, 3 plus 4. And also you can make the differences. Guys, this NumPy is very special, and it will work wonders. Why? Because mathematical operations or the statistical operations are more in Python, particularly in the machine learning. Okay, so playing with these numbers and understanding the existing indexing and slicing operations or the mathematical operations is very important. So try to do more practice of these programs. Okay, so difference will also work in the same way, different accesses and all stuff. Log 1, can you please tell me what is the value of log 1? 0. Log 2 of 2, so it should show 1, 2, 3, right or wrong? Okay, are we good so far? Linear algebra, take a look at this part. Dot, which is representing a dot product of two arrays. 5 into 2, 20. See here I do have an array, multi-dimensional array. Okay, it will give my multiplication of multiple arrays, almost matrix multiplication. Okay, this is none other than a dot product of two vectors. Okay, so in this example, 1 into 1 plus 2 into 1 plus 3 into 1 plus 4 into 1. So coming this here, you could see that what is the a value is here, which is a 1 by 2. This is also 1 by 2. NP inner, this will return your inner product of two arrays. Okay, inner of a comma b. Next, you can see 3 into 3 9, 2 into 2 4, 1 into 1, sum up all together you will get 14. Okay, likewise, if you just go ahead and producting all this stuff, you will get, why? Because this is a and this is b. When you're doing the inner product, okay, the fourth corner you will going to get 1, and here you are going to get 5. 1 into 0, 2 into 1, 3 into 1, 2 plus 3 5. Okay, cross. Okay, make it side by side so that you would be understanding how exactly is going in. 1 into 0, 2 into 0, 3 into 1, 3. Okay, 1 into 0, 2 into 1, 3 into 1, 5. 1 into, no, 0 into 0, 1 into 0, 1 into 1. You're going to get 1. This is the inner product, outer product of two values. Outer product of the two vectors. Matrix product of two arrays. This is generally the one which we generally do it. This is the same stuff. Can you please tell me here, A matrix is showing us 2 by 1 by 2 matrix. This is 1 by 2 and this is 2 by 2. 2 by 2 and 1 by 2. What is the resultant matrix? When I say mat multiplication of A comma B, A is 2 by 2, 1 by 2, 2 by 1. A comma B, right? One by two, it is representing in a different way. Let us try making this one into 1 by 2 and 2 by 2 and 1 by 2. 2 by 2 into 1 by 2, we are going to get 1 by 2, and 1 by 2 into 2 by 2, you are going to get 1 by 2. Okay. All of you good so far? Do you have any confusions over here? 2 by 2 and 1 by 2, you will get 1 by 2. 1 by 2 and 2 by 2, you will get 1 by 2. Right? So np.random integers between 2 and 10. Whenever you execute, it will give us a different integer. Okay. So next one, random integer 1 comma size is equal to 1 comma 2 comma 3. Whenever I mention the size 1 comma 2 comma 3 represents a different style of matrix. You should understand here. Okay. A size of 3 by 2 by, see how it is going to work. We should be carefully understand this part. This is a three-dimensional, and you should observe how many braces are there. Within one brace, it is 1, 2. Okay, so this brace is going to end up here. Okay, so you are having one item in each and every row. So you have 3 rows. In each and every row, you are going to have 2 elements inside that. 3 by 2 by 1. 1 represents one particular column. Whereas here, you're going to have everything in a one particular 1 by 2. First of all, we have to understand 1 by 2. One row and two elements and 3 columns that you can understand. See here, this is a one element. Okay. And this is another element. 2 elements within a array. That is 1 by 2. And you are representing everything within 3 different braces. You have to understand this one. Okay, even in the 3 by 2 mode, you are having something like this: 1 row, 2 row, 3 row, 3 by 2. Each and every element consists 2 columns. Okay, and all of this will consist within a single row. Okay, are you all clear with this? Tensor dot of axis 1 comma 1. What is the shape of this? 1 comma 3 comma 3 comma 1. 4 dimension. Okay. Are you all good with this? We still have a couple of more programs. Do you have any questions so far? Do you want me to continue with other programs? Let me cover up with this NumPy as NP. Guys, are you all good with the linear algebra? And so far, mathematical operations or the arithmetic operations that we have performed on the relative arrays. Anusha, Ashok, Ram Dinesh, Sunil, Suresh. Okay, take a look at this one. I just want to arrange some data here. 0, comma 1, 2, comma 3. Okay, range of 0, 2 by 2 shape. Okay, so what is the minimum value? 0. What is the maximum value? 3. Okay, what is the minimum value with axis 0? 0, comma 1. What is the minimum value with axis 0? 2, comma 3. Maximum value. What is the maximum value with axis 1? 1, comma 3. Okay, in the same way, we have a one more array. Okay, in which I just wanted to understand the median. Okay, when I'm understanding this median, the median is 3.5. Here the average and the mean, standard deviation and variance. All of you understand this? Hmm? These are all very basic statistical operations that we can perform with the NumPy. We have already covered this string functions anyhow. Okay, now let us take a look at the sorting, searching and counting operations. See, we have 6, 4, 3, 2 in an array, which is a 2 by 2 matrix. Sort of x. See how it was sorted? Earlier it is in the descending order, it was now sorted in a different order. Means each and every row was in an increasing order, you can understand. Sort not by axis, none. So there is no axis now. It's everything is a single row. Axis is equal to 0. Only it has to perform within the 0 axis. So 3 and 6 tilted. Okay. I mean 3 by 2 comma 6 comma 4 is tilted. Argmax 0. So now array of 0 comma 0 axis. See, argmax is none other than indices Okay, indices of the maximum values along an axis. Here, what are the maximum values here along the axis? 3 and 6. Along the axis, we are having 3, 2 and 6, 4 is the total data or the values. Okay. Out of which, if you are going to check, argmax will give us the maximum values along one particular axis, where it has to provide us based upon the axis is equal to 0. Here, let me just show you what is the, when you say that argmax of x is equal to 0, obviously whatever that you are going to find out within the axis will become 0. Count underscore non-zero. 4. Why? Because when you understand an I, it will consist all the ones in the diagonal format. Count non-zero in your own represented array. How many non-zero values are there? 5 values are there. NP dot matrix, you can convert into a matrix of the given values within a 0, 0 by, 1 by 4. This is an array. As a matrix of this array. Anyhow, that is how an array has been converted into a matrix. You can convert an array into a matrix, something like this. Okay. Switching to the broadcasting. See, you have something called np.array 0, 10, 20, 30. B is equal to np.array 0, 1, 2. You have two different arrays. Let me execute them first. 0, 10, 20, 30 and 0, 1, 2. Okay, we have two different stuff. A plus B represents addition of all the earlier elements along with the array. A plus B. Okay. A minus B. See, whenever you see a broadcasting, it is not just like a general multiplication of a matrices or an arrays. Okay. 0 plus 0, 0. 0 plus 1, 1. 0 plus 2, 2. 10 plus 0, 10. 10 plus 1, 11. 10 plus 2, 12. Something like this. In the same way, even A minus B works out, and also A plus A into B works out. Okay. All of you understand this broadcasting. Each and every element would be something like a cross join. Okay. Each and every element of the first matrix should be multiplied, or the addition, or the doing the mathematical operation with the opposite element. Okay. Are you all good with this? Okay. Matlib in mat library in numpy.py. Mat library in numpy.py. So anyhow, that we are going to cover this matlab separately. Okay. Hence, still, I just wanted to show you this matplotlib, how it is going to work out. Empty, mb.empty of 2, 2. Okay. 2, 2 integer. Mat library is almost like a matrix. Okay, and we have one more thing, which is the visual kind of stuff, and so this is a different, and that is different. That is matplotlib, and this is matlib. So you have to understand this difference. So here, this below function, which will generating the random data for you. Let me show you. See, the data is not common. Okay, zeros, all zeros, 3 by 3. Only I want, but I want integers. Okay, I want integers. I got the integers now. I just all the ones, mp.ones. I want all the ones to be integers. I want an I, mp.I. I'm sorry. I want that I to be an integer. I want an identity, means a squared identity matrix. 3. I is giving a one type of way, and this is another way. Okay, identity. Random values of 2 by 3 matrix. Random values, you will get the random values. If you want the integer random values, you also can get the integer type of the random values. One second, I think that we are not getting the same. This is not giving the integers, rather it is giving different types of elements anyhow. This integer is not working over here. We are getting only the random elements, however it is. There's not much difference. It's not giving that. Okay. I think I need to provide here particularly, in particular, d type equal to integer. Otherwise, it is not going to give us something like that. And also, but it is not allowing even the module itself is not allowing something like this. It looks like. Let me check what then 64. No, it is not at all there actually. Let me give it here somewhere like this. No, it is not there. Random integer values. See, the rand variable itself, it should have something like that. Rand NumPy mathlib. See, it is just is having arguments. It does not have any sort of such kind of stuff. So you don't have this kind of option. Okay, let me remove that one. Okay, all of you. Maybe I might have tested with that part earlier. Nothing more than that. That's it. So we have done the NumPy part, and we are left with the pandas. Okay, how do we access the files? And the next one is matplotlib. Okay, okay, guys. See you again on Thursday. See you all. Bye.